Welcome back, everyone, to the Deep Dive. You sent over some seriously thought-provoking articles about whether you need to be a math genius to learn how to code.
Oh, yeah.
hmm I think it's a question a lot of us have wondered about, right? Like, is coding all about complex equations and algorithms and all that?
It's definitely a common concern I hear. It can be a little intimidating, honestly.
For sure, especially for beginners. But that's exactly what we're diving into today. This main article, Why You Don't Need to Be a Math Genius to Code, really breaks it down.
Mm-hmm.
Have you ever felt held back by that whole math stereotype?
Oh, absolutely. I mean, who hasn't, right? I hear it all the time. But the good news is the reality of coding is a lot more approachable than people might think.
Right. So this article starts by taking us way back, like to the early days of programming.
Okay, yeah.
And admittedly, back then, a lot of the people involved were mathematicians
Yeah.
working on some pretty intense problems. But what's fascinating is how much the field of programming has evolved since then.
It really has. It's kind of mind-blowing when you think about it, We've gone from like pure number crunching to this incredible diversity of applications. I mean, everything from designing websites,
Oh.
to creating those super realistic video games that we all love,
Yeah.
data analysis, even controlling robots.
I know. It's pretty crazy. So with such a range of things you can do with code, does
Yeah.
the math requirement really change that much from like task to task?
Oh, it absolutely does. The article makes a really great point about this. Yes, advanced math is essential for certain areas like game development
Yeah, it makes sense.
or cryptography, right? Anything where you're really getting into the nitty-gritty of how things work at like a fundamental level.
Mhm.
But honestly, the vast majority of coding doesn't require a PhD in calculus.
Okay, that's reassuring. So then what are the skills that really matter if it's not all about equations?
Well, the article outlines 5 core components, and they're a lot more relatable than you might think. Logical thinking, problem solving, pattern recognition, attention to detail, and persistence.
Wait, hold on. So you're saying if I can plan a trip
Yeah.
or follow a recipe, I'm already exercising some of the mental muscles I need to code.
Exactly. It's those everyday skills that really translate well into coding. And to really illustrate this, the article gives this great example of building a simple website using a language called HTML.
Okay.
Yeah.
And it emphasizes how it's all about understanding structure and syntax.
Okay, can we pause on syntax for just a sec?
Oh, sure. Yeah.
I feel like that's one of those words that can be a bit confusing for someone who's like brand new to the coding world. What does that even mean?
That's a great point. It's easy to get caught up in the jargon, right? So basically, think of syntax in coding like grammar in a spoken language.
Mhm.
It's the specific rules about how you arrange words and symbols to create instructions that the computer can understand.
Okay.
So in HTML, you use tags to structure your content. It's kind of like using punctuation in a sentence.
Okay, so building a website with HTML is more like constructing a well-organized sentence than solving a complex equation.
Precisely.
Yeah.
You got it.
Gotcha.
And you know what? Platforms like Algo Academy, they really lean into this idea of making coding accessible.
Okay, yeah. Uh-huh.
They focus on those core skills we mentioned, and they do it through interactive tutorials. And get this, they even use AI to help you as you learn,
Oh, wow.
which can make the whole process a lot less intimidating, especially if you're just starting out. Have you ever used Algo Academy?
I haven't, but I've heard great things. It's one of those platforms that teaches you the practical skills you need to code, right?
Mhm.
Like less about theory and more about actually building stuff.
You got it. It's all about learning by doing,
Yeah.
which can be so effective and engaging, especially for those who might be, a little hesitant to dive into the theoretical side of computer science.
Right. All right. So we've established you don't need to be some kind of math prodigy to code.
Right.
But this article does have a section called The Math You Actually Need for Coding, which I have to admit makes me a little nervous. What do you think? Should we be worried?
Not at all. The good news is it boils down to some pretty familiar concepts, basic arithmetic, a touch of algebra,
Okay.
and then something called Boolean logic.
Boolean logic. That sounds intimidating.
It's not as scary as it sounds. Imagine you're searching for something online, and you use words like and, or to narrow down your results. That's Boolean logic.
Oh.
It's about using simple conditions like true or false to control how your code behaves. So in coding, we use these logical operators like and, or, and not to make decisions and execute different parts of our code based on certain conditions.
Okay, so it's more about like common sense decision making than remembering complicated formulas.
Exactly. And here's the really reassuring part. Modern programming languages and libraries, they actually do a lot of the heavy lifting for you when it comes to those complex math functions. They, what we call, abstract away the complicated stuff so you can use them without needing to write out all the like nitty-gritty mathematical details yourself.
Could you give me an example of that, like how
Right.
that actually works?
Absolutely. Let's say you're working with a data set, maybe sales figures from a spreadsheet, and you want to calculate the average sale. Using Python, which is a programming language, and a library called Pandas, which is basically like a toolbox for data analysis, you can do this with just a few lines of code. Pandas already has a built-in function for calculating averages. You don't need to write out a long, complex formula yourself. It's like having a super smart calculator that understands exactly what you need.
That makes sense.
Mhm.
So the language itself helps you out by handling a lot of the background math. But I got to say, even if the math isn't as intense as some people might think, that whole I'm not good at math feeling can be a real mental block. Like, what does the article suggest for dealing with that?
Well, I'll give some really practical advice. First, it encourages you to shift your focus from math to problem solving. Instead of getting caught up in the numbers, think about the logic behind the code and the steps you need to take to achieve a specific goal.
So it's more about the process of breaking down a problem and figuring out a solution.
Exactly. And that leads to the second piece of advice, which is to start with user-friendly languages like Python or Ruby. They're known for being very readable, meaning the code is actually pretty easy to understand even for beginners. Plus, they have a more intuitive syntax, which can make the learning curve less steep.
So instead of getting bogged down in like complex syntax and feeling overwhelmed, these languages allow you to focus on the problem-solving aspect of coding.
Right. And finally, the article emphasizes project-based learning. It encourages you to jump in and start building things rather than getting stuck in theory.
So the best way to overcome the fear of math in coding is to actually start coding.
Absolutely. By working on real projects, you'll see firsthand that most coding tasks don't require you to solve complicated equations. And that brings us back to Algo Academy. It's fantastic for this kind of project-based learning. They emphasize something called algorithmic thinking, which honestly is another term that sounds a lot more intimidating than it actually is.
Okay, before we move on, can we break down what algorithmic thinking even means? It sounds very computer science textbooky.
You're right, it does sound a bit complex, but it's a skill we use all the time in our daily lives. Let me give you an example. Imagine you're making a sandwich.
Okay.
You have a specific set of steps that you follow. You get the bread, you spread the butter or mayo, you add your fillings, you put the slices together, and voila, you have a sandwich. That's essentially an algorithm.
So algorithmic thinking is basically just about breaking down a task into a logical sequence of steps.
Exactly. It's like a recipe for solving a problem. And Algo Academy helps you develop this skill through interactive exercises and coding challenges. You'll learn how to identify patterns, create logical steps, and basically teach the computer how to solve specific problems.
So it's not about memorizing formulas or being a math whiz. It's about developing that step-by-step problem-solving mindset.
Precisely. And as you work through these exercises, you'll see how those coding concepts translate into practical skills that you can use to build real things. It's incredibly empowering.
All right, this is all making a lot more sense now. But, before we get too carried away with this idea that you can completely avoid math and coding, I think it's fair to acknowledge that the article does mention some areas where those skills can be really beneficial.
Yes, it's important to be transparent about that. As we touched on earlier, fields like game development, data science, cryptography, computer graphics, and algorithm optimization often do require a stronger math background.
Okay, so while the main takeaway is that you don't need to be a math genius to code, it's good to know that there are certain areas where those skills can give you an edge.
Exactly.
But those are more specialized areas, right?
They are. And remember, even in those fields, the level of math required might not be as daunting as some people imagine.
That's a relief. It seems like a lot of the anxiety surrounding math and coding comes from this misconception that you need to be like some kind of calculus guru to even get started.
You hit the nail on the head. But what's so encouraging about this article and what we've been discussing is that there are so many paths within the world of coding, and it's all about finding the one that aligns with your skills and interests.
I love that. It's about breaking down those barriers and empowering anyone who's curious about coding to explore those possibilities regardless of their math background.
Absolutely. Yeah, exactly. Speaking of finding your path in coding, it's interesting to think about the different ways people learn best. Like some folks, they really thrive in those self-paced solo environments,
Right.
while others really benefit from a more collaborative approach.
You're actually reminding me of another article that you flagged. Is the learning to code alone method overrated? It made me think about the potential downsides of going it alone, versus finding like a supportive community. What stood out to you in that piece?
That's a good one. The article makes a really compelling case for like finding a balance.
Hmm.
While self-directed learning can be incredibly valuable, you set your own pace, you explore topics that interest you, there's also so much to be gained from working with others.
Right.
It highlights how collaboration can expose you to different approaches to problem solving,
Hmm.
help you troubleshoot those like inevitable coding roadblocks that you're going to run into
Oh, sure.
more effectively, and even just like boost your motivation when you're feeling stuck.
Yeah, it's like having a coding buddy, right? Someone to bounce ideas off of, to celebrate those aha moments with.
Exactly. And this ties back to what we were just talking about, like building a more inclusive and supportive coding community as a whole. We need to create spaces where people feel comfortable asking questions, sharing their struggles, and learning from each other's experiences, no matter their background or skill level.
Yeah, I love that. Speaking of struggles, this next article really hit home for me. Why failure is essential in the journey to learn to code. I think we often put so much pressure on ourselves to get things right on the first try, but in reality, coding is all about trial and error.
So true. This article brilliantly points out that failure isn't the opposite of success.
Yeah.
It's practically a stepping stone towards success.
Mm.
It's through those quote unquote failures, those bugs, those errors, those moments where you're just like banging your head against the keyboard,
Oh, yeah.
that we gain deeper insights, we develop our problem solving muscles, and ultimately become more resilient coders.
It's all about embracing that growth mindset, right?
Yeah.
Seeing those errors not as setbacks, but as opportunities to learn and improve.
Precisely. And the article offers some really practical tips for like reframing your relationship with failure. One that stood out to me was the idea of keeping a bug journal.
A bug journal.
Yeah.
Okay, I have to admit, that sounds a little nerdy.
I know, right? But hear me out. It's actually a really brilliant strategy. The idea is to document the errors you encounter, the steps you took to troubleshoot them, and the solutions you find.
Okay.
It might feel tedious in the moment, but over time, you build up this incredible resource that you can refer back to.
So next time you encounter a similar bug, you can just pull out your trusty bug journal and be like, aha,
Yeah.
I've seen this before. I know what to do.
Exactly. It turns those frustrating moments into valuable learning experiences.
That's really smart.
And it encourages you to reflect on your process and identify like patterns in your mistakes. You might start to notice that you tend to make the same types of errors, which can help you focus on strengthening those areas.
It's like building your own personal coding knowledge base.
Right. And the article also highlights the importance of seeking feedback from others, even when it can be a little tough to hear. Constructive criticism from fellow coders, whether they're more experienced or just starting out like you, can be invaluable for identifying blind spots and, just honing your skills.
Okay, so we've talked about the mindset, we've talked about the learning strategies, but I think it's time to tackle a question that I know a lot of beginners have. What programming language should I learn first? I mean, there are so many options out there. It can be overwhelming. You flagged this article. Should you avoid high-level languages as a beginner? What are your thoughts on that?
Oh, that's a question that sparks like endless debates in the coding world. Some people, they believe that you should start with a lower level language like C or assembly.
Yeah.
Their argument is that it gives you a deeper understanding of how computers work at like a fundamental level. You're closer to the hardware, closer to the ones and zeros.
Yeah?
But this article presents a really compelling counter-argument.
Okay, I'm intrigued. Tell me more.
Hmm?
What's the case for starting with a higher level language?
Well, the author argues that for most beginners, starting with a higher level language like Python or Ruby can be a much smoother and frankly more enjoyable experience.
Okay.
Remember how we talked about syntax being like grammar? Well, these languages are known for being very readable and having intuitive syntax, which can make the learning process less daunting. Plus, they come with extensive libraries. Think of them as pre-built sets of tools that handle a lot of common coding tasks.
So if I'm understanding correctly,
Mhm.
starting with a higher level language allows you to focus on like grasping the core concepts of programming without getting bogged down in the like nitty-gritty details of how the computer actually executes those commands.
You got it. It's like learning to drive an automatic car before you dive into a manual transmission.
That's a great analogy.
Yeah.
And, once you have that solid foundation in programming principles, the logic, the problem solving, the ability to think algorithmically, you can always delve deeper into those lower level languages if you want to.
Exactly.
But for many coding applications, those higher level languages are incredibly powerful and efficient.
For sure.
It's all about choosing the right tool for the job. And for beginners, a higher level language might just be the perfect on-ramp to the coding world. It's fascinating how there's no one-size-fits-all approach to learning to code. It's all about finding what works best for you. But regardless of which language you choose, there's another article here. Is coding memorization a misleading goal for newbies? It challenges a pretty common assumption about coding. What's the key takeaway there?
Oh, this one really resonated with me. It argues that focusing too much on memorizing syntax or like specific code snippets can actually be counterproductive. True coding proficiency isn't about having a photographic memory for every line of code. It's about developing a deep understanding of the underlying concepts and principles. It's about being able to apply those concepts to solve a wide range of problems, not just regurgitate lines of code from memory.
So it's not about becoming like a walking code encyclopedia.
Right.
It's about building that like flexible problem-solving mindset that allows you to adapt and learn new things as you go.
Exactly. The article suggests some great strategies for shifting away from rote memorization and towards a more conceptual understanding.
Yeah.
One that I found really helpful was the idea of explaining code to someone else.
Now that's interesting. How does explaining code to someone else actually help you learn better?
Well, think about it. When you have to articulate a concept to someone else, you're forced to break it down into its fundamental parts, right?
Right.
You have to really understand it yourself in order to explain it in a way that makes sense to someone who might not have the same background knowledge. This process can be incredibly powerful for solidifying your own understanding and identifying any gaps in your knowledge.
It's like that classic saying, the best way to learn something is to teach it.
Oh.
By putting yourself in the teacher's shoes, you're forced to confront your own assumptions and really grapple with the material.
Precisely. And the article also highlights the importance of consistent practice. The more you code, the more familiar you become with different patterns, problem-solving approaches, and yes, even syntax. It becomes less about consciously remembering every detail and more about developing that intuitive sense of how to approach coding challenges. It's like learning a musical instrument. The more you practice, the more those finger movements become second nature.
Okay, we've covered a lot of ground here. We've debunked the myth that you need to be a math genius to code, explored the power of collaboration and mentorship, and even tackled the age-old question of which programming language to learn first. But before we wrap up this fascinating exploration, I want to circle back to the idea of coding communities. We touched on this earlier, but I think it's worth diving a bit deeper.
Are you thinking about that article, Are Coding Communities Doing More Harm Than Good? It definitely sparks some strong opinions.
Yes. It's a provocative title, and I think it raises some really important points that are worth discussing. While coding communities have the potential to be incredible resources for learning, networking, and support, they can also unintentionally create barriers for certain individuals.
Absolutely. The article talks about how these communities can sometimes develop a culture of elitism, where there's this unspoken pressure to have a certain level of knowledge or expertise before you can even participate.
It's like there's this invisible bar you have to clear before you're deemed worthy of, like being part of the club.
Yeah.
And that can be incredibly intimidating for beginners who are just starting out and maybe don't feel confident enough to ask questions or admit that they're struggling.
Right. It creates this vicious cycle where people who don't already fit in might feel discouraged from even trying to join the community in the first place. And that's a real shame because these communities have so much potential to be inclusive and supportive spaces for learners of all levels.
So what can we do to address this issue and create a more welcoming environment for everyone who's interested in coding?
Well, I think it starts with awareness. We need to acknowledge that these dynamics exist within some coding communities and make a conscious effort to change them. The article suggests some concrete steps, like establishing clear guidelines for communication,
Okay.
creating dedicated spaces specifically for beginners to ask questions without feeling intimidated, and actively encouraging members to share their experiences and support each other regardless of their skill level.
It's about fostering a culture of like empathy and understanding where everyone feels valued and respected regardless of where they are in their coding journey.
Exactly. And I think it's also important to recognize that the responsibility doesn't just lie with the community leaders or organizers. We all have a role to play in creating a more inclusive and supportive environment.
So it's not just about setting rules, it's about actively promoting a culture of inclusivity where everyone feels comfortable being themselves and asking for help when they need it.
That's a great way to put it. We can all strive to be more welcoming and encouraging to newcomers, share our knowledge and expertise freely, and create a space where everyone feels comfortable asking those dumb questions that honestly we all had when we were first starting out.
It's about remembering that everyone starts somewhere and that the coding community as a whole is stronger and more vibrant when it embraces diversity and welcomes learners of all backgrounds and skill levels. It really is. It's inspiring to think about the power of a truly inclusive coding community. It's like this collective brain trust where everyone can contribute and learn from each other.
It is.
And speaking of learning, before we wrap up our deep dive today, I thought it'd be fun to tackle some questions from our listeners. Are you ready for this?
Absolutely. I love hearing what's on people's minds. It's a chance to connect with our audience and address those real-world challenges that so many aspiring coders are facing.
Okay, here's one that I think a lot of folks can relate to. I'm feeling totally overwhelmed by all the different coding resources out there. Where do I even start? What advice would you give to someone who's feeling, lost in the coding jungle?
It's a really common feeling, especially when you're first starting out. The sheer volume of information can be paralyzing. My first piece of advice would be take a deep breath and remember you don't need to learn everything at once. Start by identifying your goals, like what do you actually want to build or create with code?
So instead of trying to master every programming language and framework out there, focus on what actually excites you.
Exactly. Having a clear objective will help you narrow down your options and choose a path that feels meaningful and motivating. Once you have a better sense of direction, you can start exploring resources that align with your chosen path. Platforms like Academy, which we talked about earlier, are fantastic for structured learning, while online communities and forums can be great for connecting with other coders and getting support.
Yeah, I remember when I was first learning to code, I stumbled upon this amazing online forum.
Oh, yeah.
People were sharing their projects, asking for help, offering advice. It was like having this virtual support group.
Yeah.
It really helped me through those early stages when I felt like I was constantly hitting roadblocks.
I love that. Those kinds of communities can be such a valuable resource, especially when you're feeling stuck or discouraged. And, don't underestimate the power of good old-fashioned books and tutorials. There are so many amazing resources out there that can provide a solid foundation in programming concepts, and they're often written in a way that's much more approachable than those dry technical manuals.
Oh, totally. I'm a big fan of those books that explain complex concepts using
Yeah.
analogies or real-world examples.
Me too.
It helps make the information so much more relatable, especially for visual learners like me.
I agree. Those kinds of resources can be game changers. And here's another tip. Don't be afraid to experiment and try different things. Coding is all about hands-on learning. So dive in, play around with different languages and tools, and see what sparks your interest.
It's like trying on different hats until you find one that fits just right.
Exactly.
Okay, here's another question from a listener. I'm worried about the math aspect of coding. Are there any resources that can help me brush up on those skills? Any recommendations?
Of course. We talked earlier about how you don't need to be a math whiz to code, but having a solid foundation in certain math concepts can definitely be helpful. Academy is an incredible free resource that offers comprehensive courses on everything from basic arithmetic to calculus. It's a great place to start if you want to refresh your math skills or fill in any gaps in your knowledge.
Khan Academy is awesome. It's like having a personal tutor available, 24/7.
Right. And there are also some coding-specific platforms like Codecademy and Free Code Camp that incorporate math concepts into their lessons so you can learn those skills in a context that's directly relevant to coding.
Yeah, that's a good point.
Yeah.
It helps you see how those abstract math concepts actually translate into practical coding skills.
Exactly. And, don't forget about those amazing YouTube channels that break down complex math topics into, like, bite-sized, easy-to-understand pieces. Sometimes all it takes is a fresh perspective and a different way of explaining things to make those concepts click.
Totally. I'm a huge fan of those visual explanations that use animations and diagrams.
Yeah.
It's like watching a mini documentary about math, which is way more engaging than staring at a textbook.
I know. And remember, as we've discussed, for many coding applications, you don't need to be a math whiz. It's more about developing that logical thinking and problem-solving mindset. But having a solid foundation in math can certainly open doors and expand your possibilities within the coding world.
Okay, last question for today. What advice would you give to someone who's feeling discouraged or stuck in their coding journey? Yeah, we all hit those roadblocks from time to time, so what strategies can help us push through those moments and come out stronger on the other side?
This is such an important question. It's so easy to get discouraged when you're learning to code, especially when you're facing like a particularly stubborn bug or feeling like you're not making progress. First and foremost, remember that you are not alone. Every coder, even the most experienced ones, faces challenges and setbacks. It's part of the journey.
It's like that saying, the only way to avoid making mistakes is to stop trying. And in coding, as in life, mistakes are often our greatest teachers.
I love that. And here are a few practical tips for those moments when you're feeling stuck. Break down your problem into smaller, more manageable steps. Sometimes just tackling one piece of the puzzle at a time can help you gain momentum and feel a sense of accomplishment. Don't be afraid to seek out help from other coders or online communities. There's no shame in asking for help, and chances are someone out there has faced a similar challenge and can offer guidance.
It's like having a team of cheerleaders on the sidelines rooting for you.
Exactly. And sometimes the best thing you can do is just take a break. Step away from the code for a bit and come back with fresh eyes. It's amazing how a change of scenery or even just a good night's sleep can help you approach a problem from a new angle.
Oh, I know. I can't tell you how many times I've been wrestling with a bug for hours, only to step away, do something completely different, and then come back with a sudden flash of insight. It's like your brain needs that time to process and make those connections in the background.
It's so true. And most importantly, don't give up. Coding is a journey, not a destination. There will be ups and downs along the way, but with persistence, curiosity, and a supportive community, you can achieve amazing things.
Thank you so much for joining us on this deep dive into the world of coding. We hope you've gained some valuable insights, debunked some myths, and feel inspired to embark on your own coding adventures. Remember, you don't need to be a math genius to code. All you need is curiosity, a willingness to learn, and a passion for creating. So go out there, explore, experiment, and build something amazing.